All right, so today I'm going to talk about building data apps using React. And more specifically, building React apps that bring millions of rows from your warehouse without needing to write any server-side code. I'm Rohit Pujari, I'm the founder of Semaphore. We work with customers who have the need to provide customer-facing analytics to their customers. So I'll give an example where we work with a lot of scrap yards in the area. So if you've taken a train from suburbs to Chicago, or from here to the burbs, you're going to find at least a couple of scrap yards in the area. And scrap yards is an interesting business. You have trucks rolling in, bringing metal, and then you have commodities markets that sell and buy copper, aluminum, different grades. These scrap yards process the scrap metal, turn that into finished product, and sell it to manufacturing companies. Why do they do that? Is because recycling scrap is much more viable and it's less heavy from a regulatory standpoint to send the metal to manufacturing facilities. So today we're going to kind of take a look at from a scrapyard perspective, where you have trucks rolling in, where each truck constitutes a financial transaction, how much load they're bringing in, what's the tear, what's the value of the metal grade, and what is the yield. So all of this information needs to be processed. And we work with the companies that provide ERP or system of record for these companies. We also work with airports. If you're managing airports, you have inventory, repair schedules. So all these data-heavy operations require customer-facing analytics. So our customers tell us that our end users have diverse needs for the way they want to see the data. And there's no one dashboard that can satisfy each one of those customers. So their customer success managers, they end up creating multiple dashboards, but then it gets super time consuming because for each one of the customers, you have to create an artifact that has to flow through engineering, build, deploy, and it's just not very technical. So they use companies like us, for example, I'm representing Semaphore here, to provide customer-facing analytics. Up until now, if you've seen, customer-facing analytics has traditionally been through iframe approach, where you have a dashboard built via an iframe, and you embed that iframe into your product. So iframe provides a very strong isolation because iframes are independent of the application they reside in. So there's a strong security boundary between your application and the iframe that provides the insights. But iframe also brings a few challenges with regards to the artifacts that need to be styled and responsive. So you run into issues such as not matching to the brand, to the identity of the applications. In the last couple of years though, a lot has changed. Building a dashboard has never been easier. And I think it's going to be true as we go along, because if any one of you have built agents internally for processing your doing a work, which could be calling some APIs, bringing context, and performing an action, more and more as agents are taking upon work, we need a way to manage those agents. We need a way to track performance of those agents. So if you've built the agents, you realize that you've also built or had some sort of a dashboard to keep track of what that agent is doing. So for example, within the company, we use agentic approach to manage our CRM. So as agents are capturing the call records, they are capturing the entries, we need to know how those agents have performed, how many calls we have, what stage the pipeline is in. So agents are doing the work, but there has to be a visual representation of the data, because that's how we as humans understand data. But building dashboards has never been easier. Today, if you have Copilot or Cloud Code, you can provide a CSV file that's going to bring you a great looking dashboard with charts, filters, and it's going to be awesome. But building charts is not the hard part. And the reason for that is because when you are working in a real warehouse setup, your data is not in a CSV file. You have fact tables, you have dimension tables. Those are arranged and connected in a configuration. So it's very hard when you have an app that references dimensions from one table connected to the fact tables and be able to present that insight to the end users. And why is that? It's because LLMs are really, really good at generating SQL. They're excellent at generating SQL because that's the prior for those models. So if you let an agent generate SQL, it's going to aggressively generate the most sophisticated SQL you can find. And it will work. It will absolutely work. But you cannot guarantee the reproducibility of that code. Because when your codex changes from 5.5 to 5.6, you're going to have a very different response. So yeah, it works great in demo, but will cause a lot of issues in production. And we've seen that. We've seen that as we've encountered our own trials and tribulations. We started with generating SQL and we got very happy with, yes, we can generate SQL now. And I'm sure you've seen a lot of demos out there where agents are generating SQL and yes, this is the best thing since sliced bread. But there is also a study by Claude, I think came out a few days ago, where they have measured the performance and the accuracy of SQL when you are generating SQL over 300 tables with 1,500 different facts and dimensions. That's when the models tend to confuse because they don't understand the definition and the identity of the columns and the knowledge of how those connect. So that's why we try really hard not to let LLMs generate SQL because we want verifiability. We want to make sure what we generate is grounded, is reasonable, and has the factor of trust. So going back to the point, building dashboard has never been easier. You can generate it today. As we are going through this conference, if you have Claude open, just ask it, here's my customer data, build a dashboard. It's going to generate an amazing dashboard. You can also say, make it look like Northwoods, carve it in a wooden block and make the cars look like as though they are engraved in the wood, and it'll do that an awesome job. If I had more time, I would have shown you the demo, but that's not where the challenges are. We talked about that. And I've also seen sometimes models will generate a wrong SQL. Sometimes, or they may generate the right SQL, but it's not correct in the context you're operating. If you're asking for a revenue, and if the definition of revenue requires you to exclude certain accounts because those accounts are partner accounts, for example, LLM will account for that. And then it becomes a human job to troubleshoot the core AI role, which is not the position you want to be in. Because I've heard a quote, and I think that's very apt for today's landscape is, generation is cheap, understanding is the most difficult part. An agent can explain it to you. It can explain it to you better than any professor out there. But it's the task for you to understand what the agent is saying. And that takes human tokens. And that's very scarce because as somebody was talking about reviews, and I've used reviews as well, an agent will relentlessly produce reviews, bring in corner cases for 45 minutes if you let it. And your brain will fry understanding what those reviews are and what the agent is asking about. You will never be able to commit that PR or commit those changes if you were to understand those reviews. And that kind of goes back to the point of human tokens are expensive, they take time. So we want to reduce as many human tokens as we can. Now, so what does AI get wrong when you try writing a raw SQL? It's gonna guess the keys incorrectly. If you have tenanted applications in the sense that we work with customers where our end users provide insights to their tenants. So think about airport. You have JFK and ORD. So when you're providing insights to JFK, you want to make sure JFK is able to see the rows that are scoped for them, and ORD is able to see the rows that are scoped for them. So we call them as tenants. So ORD is a tenant, JFK is a tenant. When you let agents write SQL, they don't understand the nuance of which rows belong to which tenant. And that definition and that architecture falls on your lap as a data team. You have to instrument row level security or schema level security based on how you're thinking about your tenancy. So effectively, if you are providing analytics within your own application or providing it as a customer-facing analytics experience, you have two choices. One is iframe embed, which you can use a product to drag and drop some visuals, create your chart, and embed that as an iframe. The second approach was build it yourself, which means you take control of UI, so you get Shatsian style amazing UI. Everyone loves that. But then you also inherit a lot of infrastructure, unglamorous work. Somebody here was talking about module loading, ad hoc module loading, and I think there was a question here about pages and server side. So if you're asking Claude to generate an app, try that today. You give it a CSV file, it's going to dump all the data in a nice table for you. But real world doesn't work that way. In your warehouse, you have a fact table that is a 1,000,000-row table there. If you were to fetch all of that data at once, you're going to crash the user's browser. So you have to have pagination built in. You need to know, how do I lazily load the data in? How do I progress the pages accordingly? I think you guys have more details, something along those lines as well. Same applies to analytics. As you're building analytics, you have to take care of these smaller affordances as to how you're loading the data. Pivot table, everyone loves that. But pivot tables, as you're expanding, and as you are expanding columns and rows, those also need to be instrumented calls for better performance. So these are all things that you needed to do. And people called that 2 years ago or 3 years ago, analytics as code, which meant you're going to use Shatsian, it looks swanky, amazing, but you're going to have to take care of multi-tenancy, server-side pagination, KPIs. Who doesn't like KPIs? But KPIs are the most complex pieces of analytics work. Because when you're looking at a KPI, you need to look at the previous period. So you're going to have to write a CTE that calculates the previous period. You're going to have the query that calculates the current period. And then contributing factor. So you've already written a giant 200-line SQL. And that is set in stone at your API layer. If customer asks for a change, you go scratching your head, you create another API. So it becomes super cumbersome. And that's where analytics as a code sounded really good, but it took a lot of time to do that. Now, when we talk about grounding, we talk about what is the meaning of the columns. Let's say in your database or data warehouse, you have 300 tables, 400 tables. Each table has like 20 columns in there. How do you know which columns are important? How do you know which tables in your warehouse are important to begin with? This is where you start to create some semantic meaning around your data. So you could say, here's how our math looks like. When we say gross revenue, that's exactly the function we mean. When we say material grade, it comes from a material, what type of material it is. What we do is we use LLMs to be able to understand and classify the context, looking at the table, looking at the rows, and that's how we build the semantic layer for your data. If you have time, you could have gone and looked at the demo, but I'm gonna, trust the slides, but that's how it works, where you use LLMs to be able to infer what the columns are, you classify them, their role, are they serving as a fact table, are they serving as a dimension table? Because you don't want to join fact and fact tables, you're going to blow up the whole cache in your database. So knowing the role of the tables, knowing the role of individual column is very important. So once you've done all of this work, that's when your data becomes ready. Granted, if you have tenant ID that identifies an individual customer, could be a group within your company or could be a partner that you serve and provide analytics to. So this is what I meant when business users look at data, they think of Excel. When a data person thinks of data, they think about this. Here you have volume, revenue, purchase count, but the actual name on the labels of the yards, the name and the labels of the customers, they're sitting in different tables. So when you create a filter, for example, if I want to filter by material called grade A copper, you need to know I have to make a join from a scrap tickets which has a material ID that connects with this table. And this is what the job you're going to assign to your favorite co-pilot. And when you have a complex representation of these entities, that's where Clark gets confused. It starts looking at the keys and starts making the joins, and it produces an amazing looking dashboard, but it's wrong because it had guessed all the wrong keys, or not some of the wrong keys. But the work then becomes you as an engineer troubleshooting behind the scenes. All right. So today we are in a place with LLMs, the help of where the technology is, where we can have the best of the both worlds. We can have the isolation, security, and the ease of use of what we had with LLMs, and we can combine that with the generation power of LLMs. But we want to make sure that we have tight guardrails in how LLM is generating the code. And that's where we're going to talk about manifests and validation loops. Manifest is a JSON file, I'm going to show it to you in a minute, which keeps the agent on track. How those columns within your warehouse are expressed, what they mean, what are the accessors. So when I'm drawing the filters, what accessors do I use and what are those called? So the model remains, or the agent remains grounded. In other words, we want to keep our agent as dumb as possible so it can do the best job of putting the layout and the look and feel of your app, but it should not make any assumptions about the data for you. So we create a loop where it allows the agent to generate the code, but before the agent hands you over the code, it runs the validation script on the semantic model to know if the right filters have been applied to the right view. So this is how we used to embed some of our dashboards. We used to tell customers, just get your dashboard and provide you auth token, which basically encapsulates security parameters. And we used to say, create a dashboard, and then off you go. Put this into your app, and your dashboard lights up. But that world has changed. Now, what you can do is, you can create a provider, which is a React concept. Folks here understand what React provider is. And then you start lining up views and inputs. And these views and inputs, as you see, if you can, from the back, you can squint, hopefully you can read. But what I'm trying to point here is that each one of these components, they're effectively backed by 10-stack query. And all the code you write is free of any SQL. It's all pure JavaScript. But each one of those components are referencing the dataset name. So here we're looking at dataset name called materials. That's where our input to the filter is coming from. You have three views here. One is a KPI view, another one is a breakdown, another one is a server-side paginated table. And as you can see, you get to provide the scrap tickets, is the dataset name. But then there is also an input called grade. So these views and these cars are filtered by the grade material. This is what we ask LLM to generate, which is as simple as it can get. So within Semaphore, the way we work and what we believe the future is going to be is that, at least for the software as a service business, people will no longer log into software. You're going to summon your favorite product by making @Semaphore @Slack. That's how it's going to work. So we are a plugin within Claude, Codex, any LLM agent that can support MCP, set of files and scripts. Those who don't know what plugins are, plugins effectively are MCP, which is the LLM API, and packaged around the scripts. Those scripts we use for validation of the data integrity of the app. And the skills.md, which you teach or provide a behavior, more effectively, I think the right word is a workflow. The .md markdown files are workflow. This is the workflow you're going to follow. Here is the MCP. That's going to give you the grounded data. And then here are the validation scripts. So before you hand over the code, I'm done, make sure you run the validation scripts, because that's where we're going to catch all the errors. Now, I'll show you an example here, which basically takes 15 minutes to build. Right? This is a Shansian-based dashboard. Right? The point is not the UI. The point is how these insights are laid out. So if you can see, I have a net revenue here that's coming from a fact table. Now, if I go to channels, we talked about channels are sitting in a different table. And when I pick marketplace, and the whole dashboard is responsive. The point here is that it's not working on a CSV file. It's working on a star schema with segregated columns. How did this happen? We didn't write any code. All we wrote is just a bunch of views. What we do is, when you define that semantic layer we talked about, assign the definitions, assign the relationships, or discover relationships, Semaphore grounding layer understand how do I express those joins. Are those one-to-one joins? Are those one-to-many joins? So without you ever having to write any backend code, we know those joins, we express those joins and resolve them. Now, this is what validation looks like. So you can see there are insights represented here. We have net revenue or summary and a bunch of other things. And we also may have a table here. Oh, there you go, it's a table. But this is a paginated table. You see that line going past? Every single call is an actual API call behind the scenes. So when I click next, you see an execute command there. Next, execute command there. Sort, execute a command there, right? I don't think I have sort here, but yeah. But you get the point. Because this is working against millions of rows of data. I can pull millions of rows of data on a browser or crashing, right? But these are all things agent has generated for us. So the way this happened is because we ask the agent to generate an analytics contract. And the analytics contract means that these are views I'm going to generate in a JSON file and send you as a manifest. And it has everything you need. It has the name of the data set, it has the name of the accessor, it has everything you need. All the agent is doing is painting the web. That's all it is doing. It's painting the DOM. It has all the keys, all the accessors already. And if it cannot produce it, you're going to see a bunch of issues here. And this UI is very much similar to if you've used TanStack Query or React Query, where you can see what your queries are. So for example, let's take a look at this table, fact borrow details. It specifically tells us that we're using item count as measure, we're using gross revenue as measure, and the dimensions are channel name or our campaign. So we precisely know by looking at the dashboard, not that it is showing the data, but which dimensions are being picked and how it is being generated. In addition to that, we can look at the raw data that was returned by the API and also the actual SQL that was run on your backend without you having to write it. So that's what it means to have a grounded way of producing data apps, that agents can write the painting of your DOM, but the actual analytics contract, knowing how to express the joins, how do I connect a filter and propagate that to the fact table, all of that is being done at this semantic layer. Right? So I'm going to conclude here with just a couple of recording that I had here. So this is how the experience of working with Semaphore looks like. You simply ask Semaphore, can you build me a data app? There's no UI, you don't need to go to the UI. It's going to lead you through the process of saying, I'm going to build, here are the charts I'm going to pick. Do you agree with it or not? And then it's also going to say, sorry, I can't really tell you the specific insight because this key is not modeled. I don't know how to connect your material to your revenue. And you're going to have to model that relationship simply via asking. So we believe the data work is going to move into your agents. All the data work is going to happen from your favorite tool. Codex, Cloud Code, Copilot, something that comes next. So that's all I had today in 15 minutes. Hope you found it valuable. Happy to take any questions.